basically having 0 on the RHS. We just need to find out the complementary function. But if it is not 0, we need to find out also the particular integral, and the total solution will be actually complementary function plus particular integral. Okay, so we have to do both. So we already have seen how to find out the complementary function. We are learning how to find out the particular integral. Now on this side it may be 0, it's easy. If it is of the form of an exponential function, let's say e to the power ax, what we have seen is we just divide this. For the solution we take e to the power ax and divide it with the symbolic form of the differential equation, and then that d is actually replaced by whatever is the coefficient of x in e to the power ax, and then that is not equal to 0, we get the answer. If that fa is equal to 0, we differentiate it once, put an x on top also, then we again get the answer. If again it's equal to 0, we differentiate it again, and we keep on doing it until and unless we get the denominator to be a non-zero value. In that way we can actually find out, and we have seen some example. That was the first type that we should know. The second type is you can actually have not an exponential function but a sine function or a cos function, and when we have it as a sine function we can actually divide it by the the form. Okay, but then the point here is that when we actually do the replacements, we don't write it down in place of d or d square as a, we just replace d square with minus of a square, minus of a square. We don't do anything with d, and then at the end whatever relation we get, we have got a d here and we know that d is equal to d dx. So in that way, okay, we can take this example, we can actually solve it, and then finally we get the entire solution. So this was the second type. Today we are going to look into another type. Okay, we are going to look into another type of particular integral. Let me just
Hello,
take this
sir.
first. Yeah,
Sir, how much has been done?
we just started. I was just talking
Okay.
about the last class, okay, and then started with the third type.
Sir,
So this
last
is
class
the
answer, can you
yeah.
please again tell
Last class did you attend?
last class? That means the classical mechanics class, are you saying?
No, no, no. I'm talking about mathematical physics.
Yes, yes, sir. Yes, sir. I have attended.
This is the one. Okay.
Okay, okay, sir.
Yeah. So let's just go to the third type now. In the third type, we actually have this symbolic form of the integral into y. Now we have seen e to the power ax. अगर होता है तो क्या करते हैं हम? Or if it's sin ax or cos ax, what we do? Today we are going to see what happens if we have something like this. Let's say x squared plus x. It's a function of x, let's say. Okay. So here also we can easily solve it. We can actually find out what is the value of y, and what we do is this: we write down x square plus of x divided by f of t. Okay, and here we are going to use the binomial expansion that we have used so many times in the previous unit. We are going to use these relations. Okay, so we will solve one problem and I think it will be more clear. Here we are also going to bring in the concept of um, integration. Okay, reciprocal of that, we are going to take it, we're going to take integration. So we again have to remember binomial expansion. Okay, please remember this, we're going to use it here also. Okay, and then 1 minus x minus 1. Don't get confused here, this is a minus, there is a minus, so everything will become plus plus. That way you can easily remember it. Okay, so best is to take a problem and solve it. Okay, let's see how we do. We'll take an example here, and let's say we have got the expression as d square minus 2d plus 3 into y is equal to x square. Okay, so if you want to find out the complementary function, just to make the answers complete, plus 3 is equal to 0, and then if we solve it we get, I think we have solved this also, minus 1 and 3. M is minus 1 and 3. Therefore the complementary function would be nothing but c1 e to the power minus x plus c2 e to the power 3x, right? And now we are going to find out the particular integral. So particular integral, this will be slightly different. Okay, let's try doing this particular integral. So for particular integral, y is equal to x square divided by, this is d square
So before
minus
3, it
of,
was plus. It was not the plus, the minus sign it was, I think.
which one?
In the exercise, that means d square minus 2d
Oh, it was
minus 3.
minus 3
Yes, sir. Otherwise, we are not getting the minus 1 and 3.
and 3. Okay, okay. Yeah, yeah, I think I made this mistake again. Yeah, that's right. We're using 3 as minus 3 here. Okay, anyway. So we're going to do the particular integral and going to find it out, right? So for this, what we do is this. The technique is this. We take one value as 1, okay? So what we're going to do is we are going to take out 1 by 3 common, and then we are going to have on the denominator, okay, you can take it as minus 1, okay, and then plus, and this is no, d square minus of 2d divided by 3, okay, this is there, and into x square. So what we can do is we can just write it down as 1 by 3 into 1 divided by or maybe I can just write it down in such a way so that we are actually going to get an exponential form. So it'll be minus 1 plus d square minus of 2d divided by 3 to the power minus 1 into x square. Okay, so this we have, and now what we can do is we can do the binomial expansion in this particular case. Okay, so what we do is we can just take this minus sign out. So if we just take this minus of here, also we can do it. We can take this minus sign out here. We'll get minus of 1 by 3, and within bracket I'll get 1 minus d square minus of 2d divided by 3 to the power minus 1 into x square. So we can take this as the second part of that binomial expression. So this is your x in this case. So we can just expand this. Okay, this is minus of 1 divided by 3, and then it's simple, right? It will be 1, then there is a minus minus, I'll make it as plus. So this would be d square minus of 2d divided by 3, okay, then plus d square minus of 2d divided by 3 whole square, and so on. Okay, so we can keep on expanding this and we can take x square. Now before I proceed, you have to think about one thing here, that this is square, x square, so d is d dx. So when I have d square, that means it is d square dx square. So d square of dx square of x square, let's say, so that means d dx of x is 2x, and then again d dx, it will be nothing but 2. But if it becomes d cubed and d3, this will answer will become 0. So that means it is only relevant, this expansion is only relevant up to the second order, right? After that it is not relevant, because you are differentiating x square, you can differentiate it only 2 times, so you cannot differentiate it the third time. So that means when I open up the bracket, I have to just take care that I am just considering the d square term. So I can just do it that way and write it down as minus of 1 by 3, and then I can take this as 1 plus, okay, so there is a d square there, no doubt, but before that we also have a 2d divided by 3. So maybe you can just write it down here. I'll just write it down in ascending order of powers. So I'll minus of 2d divided by 3 if I open the bracket, and then we have got plus of d square, and from here also, if you just try taking this out, see, this is d square. If you just expand it, this will become d to the power 4. So I don't need this term, right? But then this term will be helpful here. Okay, you'll be expanding this. This will be a square plus b square minus 2ab. So that b square term would be nothing but 2d by 3 whole square. So that means this would be nothing but 4d square divided by 3. And if you take 2ab, it will be d square into 2d, so it will become d cubed. So that will become irrelevant. This is very important, okay? This is not 3, 9. This is very important. Please try to understand this, that up to what order we should take. It will totally depend on what is on this side. This is x square, so you just need to take it up to the second order. That's it. So this is your x square, right? So what we can do is we can do certain modifications here, right? We can just maybe we can combine this this is d square by 3, sorry. You can combine these two. So if I take it, this is 1 by 3. Just check if I'm doing it correctly. That is also important. This is 1 minus 2d divided by 3, and this is d square by 3 plus 4d square divided by 9. So this is nothing but 5d square divided by 9, right? So this is plus 5d square divided by 9. So we have this, and then we can just solve it, right? So what are we going to differentiate it with? We are going to differentiate it with respect to x square. So I'll just write down x square there. So that means if I just write down equal to minus of 1 divided by 3, and within bracket it would be x square minus 2 by 3 is there, d of x square, that means d dx of x square, that means it is nothing but 2x
Sir, that is 7d
plus,
square by 9.
yeah,
So that is 7d square by 9.
uh, oh sorry, yeah, I think that, okay, this is not 9, right? This is 3. If we take the LCM 9, this will be 3 7d square by 9, correct? My mistake. This is 7, right? So that means, okay, this will be, so it is plus 7 divided by 9 d square. So that means d dx of x square is 2x, and again d dx of 2x. So that will be just 2. So that will be a constant, right? So you can just keep on simplifying this, or whatever you get the value. So it will be minus of 1 divided by 3. That's the final answer. X square minus 4 by 3x plus 14 divided by 9. This is your particular integral. So therefore, have the solution as CF plus PI. So that way you're going to get the answer. So these are the three patterns that we should actually know when we are actually solving the particular integral problem, and this is actually important. All three of them can be clubbed in together, and we can actually find out the solution as well. So let me just take a problem which might be kind of unique, because this will have all the three relations, okay? All the three particular integral technique that we have seen till now, we are going to use all three of them. So let's take an example here. The example is d cubed plus 2d square plus d into y is equal to e to the power minus x. So we got that first particular integral rule, plus cos x. We got the second particular integral rule, plus x square. We got the third particular integral rule. Okay, so this is a problem which you now need to solve. Okay, and you can keep solving. Okay, and let's solve it here also. Let's practice together. So this is m cubed. You do it on your own, okay, and tell me what's the answer you're getting. And whenever you solve, solve for both, okay. Don't just solve for particular integral, also solve for complementary function, right? So here maybe I can take m common, and this would be m square plus 2m plus 1 is equal to 0. So maybe it will be m, this is m square plus 2m, so it will be m plus m. So m plus m, so it will be m into m plus 1 plus 1 into m plus 1, right, equal to 0. So this will be m into m plus 1 square, correct, is equal to 0. So that means m will be 0 minus 1 minus 1, correct. So that means the complementary function y would be, first one is not repeated, so e to the power 0x. The second one gets repeated, so I'll just simply write it down as c2 plus c3 into x e to the power minus x. So that's my complementary function. Now I want to find out the particular integral, and if I look into the particular integral, let's say y is equal to, it's a combination of all three, so we can actually use the rules and separate them out to apply to each of these parts, okay. So the first one is e to the power minus x divided by, I will write down the symbolic form, d cubed plus 2d square plus d, then I will take a plus, and then I have cos of x divided by d cube. When you do it in exam, I'll prefer you do it in as detailed as possible so that you don't make mistakes, okay. That's very important. Don't take too many shortcuts, otherwise there are chances of error, right. X square divided by d cubed plus 2d square plus d. So we have all three of them together. Now let's just use the rules one after the other. For the first one, if you take d cubed and you take it as minus 1, you can do it by the side, okay. You see this is d cubed, that means it is a is minus 1. The first one is you have to replace whatever is d with minus of the coefficient of x, right. So if you do it, let's see what we're getting. This is minus 1 cubed plus 2 into minus 1 square plus minus 1. So it is minus 1 plus 2 minus 1. So you're going to get a 0 there. So that means you cannot have it. Let's just differentiate it once. So differentiate it once means it will be 3d square plus 4d plus 1. Now if I put minus 1, this will be minus 1 square. So this will be 3 minus 4 plus 1, right. Again it's going to be a 0, right. So that means we have to differentiate it again. So that means this would be 6d plus 4. So you cannot differentiate it once and get an answer. You have to differentiate it so many times. Then only you'll get minus 6 plus 4. So that will be minus of 2, right. So that means one differentiation is not going to work. We have to do it twice. So if I do it the first time, this would be x e to the power minus of x divided by 3d square plus 4d plus 1. I cannot use it because again if I put the values it will become 0, so that means I have to differentiate again. So that means this will become x square e to the power minus x divided by 6d plus 4. Okay, so we have done partially for this part. Let's do for the second part. Okay, in the second part the rule is whatever is d square, we have to just put there a minus of a. So we can simplify it in this way. We can just simply write it down as cos x divided by d into d square plus 2d square plus d, right. We can do it that way, and then what we do is we can just put the value of the coefficient. So the coefficient here is 1 cos x, so that means a is 1, and we put a minus in front of that. Okay, you have to remember that, don't get confused here. So we are using all three laws here. So if you do this sum, you should be confident enough to do only one of them also. This is d into minus 1, so this will become minus 1. Here also I'll replace it as minus 1. So if this is minus 1, this will become minus d, and then this will be plus of 2d square. This will remain as sorry, this will become minus 2. You can just write it down directly. Okay, so this is minus of 2, and then this is d. So in d place of d, I will write it down as d only, cannot replace anything. So this and this will get cancelled out. So I'm getting simplified forms here. Let's take the third one. Okay, in the third one we know we actually need to use binomial expansion. So what we can do is there is a d here. So when we want to do the binomial expansion, one of the terms should be 1, right? We already know it. So what you can do is you can take d common, and if I take d common here, what I'll have is 1 here, this is 1, plus is to divide this by d and this by d. If I take out d common, so this will be d square, and this would be plus of 2d, right? Everything is at the denominator, not the numerator, so I'll just put a minus 1 there so that we can use binomial expansion into x square. Done. Then plus, I will keep this as 1 divided by d, okay, and I will expand this term. So this is plus, this is minus, so it will be alternate plus or minus. So this is 1 minus, this is d square plus of 2d, plus this will be d square plus of 2d whole square, plus, and so on. Put a bracket, x square. So see, all three of them I put it in the same equation, and I've done it step by step. So the steps that I'm doing, if you do it, it will make it easy. Otherwise you have to do for each of them individually and then put it there. That also you can do, there is no harm in that, but why to do it if we can do it in one sum? Okay, so this is our final step. Let's take the next page. All of you do it on your own, very important. Okay, if you do it, then only you know how to do. Practice would be good. So we can okay, so let's keep simplifying this. Okay, let's write down equal to, okay, and then the first expression we can actually replace x square e to the power minus x. Now here we can easily replace this t with minus 1, so this would be 6 minus 6 plus 4, doesn't become 0, so it's fine, plus this is already done, we have got rid of t, this is cos x divided by minus of 2, then plus 1 divided by d. This third step is going to take some time. We're just going to take, it's x square, so that means we are just supposed to be left out with d square term. So let's see, 1 minus, I will take the ascending order, so I'll take 2d first, then minus d square. Done. Here if I expand this, this will be d to the power 4, not needed. This is expanded, so this is plus 4d square, and this will be 2d cubed, 4d cubed, so I don't need it, so it's not needed. So I'll just keep it like this and write it down as x square. So this would be nothing but x square e to the power minus x divided by minus 2 plus cos of x divided by minus 2 plus 1 divided by d, and this would be x square minus 2 times d, that means d dx of x square, that is 2x. So this will be 2 into 2, that is 4x, minus d square, so you take d dx of x square is 2x, okay, and then you take d dx of 2x is just 2, left out with 2, plus this is 4 times, and d square of x square is again 2, so it is 4 into 2, 8. Or you can just combine this and do it together, going to get the same answer, right? So we have it now. Okay, so it's almost done now. Always remember one thing here, 1 by d, when it's written that way, it's actually integration. Okay, integration. So we know that the integration and differentiation are the complement of each other. So that's why 1 by d is the integration part. So you can just take this to be x square e to the power minus x divided by minus 2 plus cos of x divided by minus 2, and then this is plus integration of x square, so that is x cube divided by 3 minus integration of x is x square divided by 2, and then this is minus 2 plus 8 is 6, and integration of a constant, this will give you an x here, right? So just cancel this out, simplify it, okay, and this is your particular integral. So I can write down y. Don't write it down this way, I'm just doing it so that we can save time. But in exam you write down y is equal to complementary function plus particular integral. Write down whatever we got as the complementary function plus this particular integral, you have to write down, and this is the entire solution for this particular problem. So what happens is that if you solve each of them individually, it takes a lot of space. Don't really need to do it, you can do it step by step, just do it slowly, okay? I've done it slowly. So preferably you also follow the same technique and it should not be a problem. So this actually brings us to the end of differential equation, but your syllabus mentions it's a second order differential equation. So let's just discuss whatever we have found out, okay, in higher order differential equation, and we will just paste it in second order differential equation idea. So let me just write down this here, so that you are not confused, okay? This is second order differential equation, differential equation. So whatever we have seen, I'm just going to revise this. Very simple. We have seen that we might have a function, okay, and it might be second order differential equation, might be something like this. Px qx might be constant also, it's not mandatory that there will be a function of x or y, not needed. I'm just writing down the general form, then you can actually get this, and then on this side we can also get some kind of constant also, that is also possible. If it's a constant or some function of x, we know the rules of finding out the particular integral, okay? So in general, when we say, I'll give you this term here, if this gx is equal to 0 and this is the form that we are getting, we basically call it as homogeneous, okay? And on the other hand, if this gx is not equal to 0, we call it as non-homogeneous. Just terms, okay, just jargons. You already know how to solve it, so even if you don't know the jargons and if I'm not asking that specifically, it's okay, if you don't remember the term. So what happens is, these constants might be, this px might be just any value a, okay, qx might be b, let's see, or rx might be c, okay? And in that way what we can do is we can actually have an equation something like this. It will depend on what kind of equations are there. See, there are so many forms, so many equations to solve, we really cannot involve every kind of problem, okay? We are just sticking to the syllabus, and that way it will become a bit easy, okay? So let's say this is equal to 0, okay, and let's just write down, let's say, okay, y is equal to e to the power rx. This is something which you have seen initially. So that means when we say y dash, we have got r e to the power rx, and y double dash is equal to r square e to the power r, sorry, e to the power rx, right? So that's the form that we actually have. It depends on what is y. If y is given, you can easily form a second order differential equation. This is actually something which is similar to whatever we have done. We have done higher order, we are just talking about second order here. So that means this is actually much more simpler. So if
So
I
that
just
is
take
y
that form,
equal to
e to the power rx, okay, just taking a form, let's say I know what is the form of y, what is that function, y is obviously a function of x, right? This is how expressions are written, so it should not be complicated. So that means in place of I can take, if I replace this y dash and y double dash by these values, I can just simply write it down as y is e to the power rx as common, and within bracket, I can write it down as a r square plus b r. I'm giving a general form. At the end you'll see that this is something which you have already done, but we have done it in the form of numerical problems, is equal to 0. Now you want to solve it. you want to solve it and find out what are the different values of r, because this is quadratic in r. Okay, so that means if I solve it and I want to find out the value of r, e to the power rx, this will become 0. This is ar square plus b square minus 4ac plus minus root over b square minus 4ac divided by 2 times of a. So this entire idea will give you how to actually approach the solution. Okay, this is what we have seen. Number one, this value, why I'm taking this, because this is a quadratic equation. We have done higher order, we have done 4 5, second order also we have done it, no doubt, but then there we did not discuss this. I'm discussing this specifically because if we talk about higher order lesson 3 and 4, you cannot really use this equation, but here we can use it when it's a second order differential equation, right? So it will entirely depend on what will be the solution, or on what is the value of root over of b square minus 4ac. So b square minus 4ac is, let's say, 0, is greater than 0. Okay, we have basically got two real roots. Okay, so we have got two real roots here because this is greater than 0. Okay, so we have got two real roots, and therefore we have got y is equal to c1 e to the power r1x plus c2 e to the power r12. This is something which you have already seen. If it's higher order, you will get other terms like c3, c4, c5 and so on. Okay, so this is the first one, and the second one is this, let's say root over of b square minus 4ac is, let's say this is equal to 0. So if this is equal to 0, you're going to get just one root. Why? Because this is equal to 0, so that means you're just going to get it as minus b by 2a. This entire term is 0. You're just going to get one root getting repeated twice, right? So that means you have y is equal to, if you just write down this one root, that means there is only one value of r, so we can just combine both of them. Okay, so in that way we basically know that this is nothing but c1 plus c2x e to the power rx. Okay, that's the one root issue. And then what is the third possibility? Third possibility is less than 0, that means it is an imaginary value. So b square minus 4ac is less than 0. Okay, that means you're going to get two roots. One is r1 is equal to alpha plus I beta, and then r2 is equal to alpha minus I beta. So you have got these two solutions. Okay, and if we just write it down, y, what is my y is equal to, you've seen the solutions, we have done it, e to the power alpha x, and then this would be nothing but c1 cos of beta x plus c2 sine of beta x. So if this entire slide explains everything, actually whatever we have done in the last 2-3 classes. Okay, if we have higher order differential equation, we basically have it as r cubed, let's say, then it will be like c1 c2 c3, this everywhere there will be 3 variables. Okay,